All right, the next type of question we're going to ask, and we're going to stop here, but is these types of curves that have inner loops and outer loops. And there's 3 different questions that they will ask you here. So they might ask you for the area, and the most common on the AP test is the area of the inner loop, is what they'll call it. Sometimes books or people call it the teardrop. A different question would be, what is the area between the loops, which would be everything except for the inner loop. Or they could ask you for everything uniformly once, like that. Nope, straight line, nice. All right, so 3 different questions. And the key to all of this is understanding how this thing is graphed. Because your formula is the same. The only formula we got here is 1/2. I think my Apple Pencil just died. All right, 1/2 the integral from alpha to beta of r squared d theta. So the only kind of rhymes, like a poem in an equation. So the only thing we got to really figure out is what alpha and beta are for these different sections. So if I were to go graph this thing, so I got r, while my pencil charges for a second, 1 minus 2 sine theta. So what I've got to be able to decide is, well, what angles are controlling what portions of this circle? So if I were to integrate, say, from just 0 to pi, it's going to give me that section. 0 to 2 pi gives me the whole thing once. All right. So the thing that's controlling, and the best way to get a good idea, is to once again set your equation for r equal to 0. R represents the radius, it's your distance from the 0. So if I'm trying to figure out when I'm going through the origin or the pole, that means my radius needs to be 0 because I'm on the pole. So I want to say 0 equals 1 minus 2 sine theta. And then I'll solve that. So 1/2 equals sine theta. Once again, we got to know our unit circles, otherwise we're at a loss. So pi over 6, 5 pi over 6. So those are the theta values that I'm hitting the pole at. Alright, so this thing's going to start at theta equals 0. So right there is theta equals 0. And it's moving along as theta increases. And theta is going to first hit the pole, or the radius first hits the pole when theta equals pi over 6. So if I were to integrate from 0 to pi over 6, what you'd be getting is this little hump. Okay, now that's not ever a question, but understand that's what's going on here. So the next thing that happens is my curve goes through the origin and hits this inner loop, and it's going to leave the pole at 5 pi over 6. Now to check this, you should be graphing it. So actually going into your window and plugging in pi over 6 to 5 pi over 6 and seeing that that's giving you the teardrop. Okay, and yours will have a little particle that'll move its way around, and it'll make more sense, but you're getting your teardrop. So if my goal was the teardrop, or the inner loop, they call it the inner loop in AP, so we'll stick with that. Then I got to do 1/2 the integral from pi over 6 to 5 pi over 6 of r, in parentheses, squared d theta. And most of these just have you set them up. Would be all you'd have to do, or plug it in the calculator. These are actually generally calculator questions. Alright, so that gives me the inner loop, because what's going on is, once I hit pi over 6, you're sketching these radii all the way around, and you're adding up all those little links, is what you just did. Alright, so a harder question. So the inner loop is the easiest question. So after that, it moves along this way. So here's theta equals pi, and then it shoots down low, and it gets back to the x-axis at 2 pi. So if you wanted the area between the loops, that's the next level of question here. That one's a little trickier. So if I just were to integrate from 0 to 2 pi, if you think about what happens there, you would start sweeping your curve as you go around, and then you would sweep out your inner loop, okay, from pi over 6 to 5 pi over 6. Then you would start sweeping out this little hump from 5 pi over 6 to pi, and then after pi, you would start sweeping out here, so from pi to 3 pi over 2, and then from 3 pi over, this is 3 pi over 2, 3 pi over 2 to 2 pi, you're going to swoop your way all the way around. Now, what happens here is that this is everything, but what? What's the problem? If what I'm looking for is the area between the loops, and I want all of this stuff only, well, we have a lot of extra. The extra we have is this includes the inner loop twice. So it includes the inner loop, not once, but twice. Think about it again, as you swept around this way, so you did the inner loop once here from pi over 6 to 5 pi over 6, and then you swept out. Well, here comes the problem. As you go back again, you're accumulating right there, this inner loop again, as you moved your way around. So you got a few options. Option 1 is you can do everything, r squared d theta, and then you can subtract out the inner loop. Two times. That would give you the green area. Okay. Option 2. You could just do everything once. So if I were to integrate here from 5 pi over 6 to, this is the tricky part, 13 pi over 6. That's this whole curve once. So let's look at that. This gets pretty, I know it's pretty tricky. So 5 pi over 6. A lot of people say 2 pi. Here's the problem with 2 pi. If you sweep all the way around to 2 pi, you're going to stop at the x-axis, and you're going to leave out that little hump at the top. So I got to go a little more, and I got to add another pi over 6 to that to get me back to the origin or the pole. So I really got to go back to 13 pi over 6. So that range would get everything once. Then you got to subtract your inner loop. Just one time. Any thoughts on that? You can use symmetry here. Like some people, if you really want to get creative or maybe complicated, it is totally, these things are crazy symmetrical. So you could like say, I'm going to find this half. I don't really know why you would want to. And then just double it. That'll totally work. There's all kinds of symmetry here and different ways to accomplish these things. But that's how you, those are the two questions here. Either the inner loop or the area between loops. They technically could find everything once. I've never heard them ask that before. It's either the inner loop or the area between the loops. All right. So just to look at what an FRQ like this would look like, this was almost always an FRQ on the AP test normally. This kind of goes through all the different polar things. So they give you a polar curve and they give you the graph of it. The weird thing about this one, so r from 0 to pi, is that theta equals 0 is right there. And then it moves this way around the origin. how do I know that? Okay, well, if you know that x equals r cosine theta, well, when theta and then x equals 1 minus 2 cosine theta, if you were to go plug in theta equals 0, such that theta equals 0, that's going to give you, so cosine of 0, we need to know is 1. 1 minus 2 times 1, negative 1. So the x-coordinate at theta is negative 1. So it's starting there. That's a little weird for some people. And then it's swooping out. So if I wanted to know where it hit the x-axis, that's where my radius is 0. So 0 equals 1 minus 2 cosine theta. So negative 1/2, which is a positive 1/2 cosine theta. So then you got to know, where does cosine theta equals 1/2? Theta equals pi over 3. So pi over 3 is the theta value where this thing hits the pole. And then it swoops its way out. The hardest part, again, about so much of calculus is all of this pre-cal or geometry or algebra that we don't know, that we were supposed to know already. So we're looking at it. But if you can understand that theta starts here and then it ends right here, some of these questions are really easy. So A just says, we'll write the expression for the area. So it's just 1/2 the integral from 0 to pi over 3 of r squared d theta. Done. 2 points. That's it. And you can use r. You don't have to write the function out since there's only one r and since they labeled it for you. All right. B says, we'll write expressions for dx dt and dy d theta. Dx d theta, dy d theta. So this is where you get the points. Write down x equals r cosine theta. Y equals r sine theta. You literally got a point for doing that. Okay. And then x equals, so now you can go write it out. And then take your derivatives. They are product rules. Don't forget, so dx d theta 4 sine theta cosine theta minus sine theta. I went ahead and did it and simplified it for you. And then dy d theta 2 sine squared theta plus cosine theta minus 2 cosine squared theta. There's B. Write an equation for the line tangent to the